Hello everyone, and in this video I'm gonna show you how to solve separable differential equations. And before we get started, let me tell you what does the word separable mean in terms of differential equations. So basically it means that you can separate the variables from each other and place one variables on one side and other variables on the other side. And let's try to apply this logic to our following equations. So let's start with the equation number 1. dy over dx is equal to x times y. So in order to proceed, we need to place all the x's on one side and all the y's on the other side. And for example, let's divide both sides by y. So times 1 over y. And will turn into dy over y times dx is equal to x. Great, but we need to get rid of this dx here and place it here somehow. So basically let's multiply both sides by dx. And we'll have dy over y is equal to x dx. And at this point you see that we have all our y's on the left hand side and all our x's on the right hand side. So we can integrate both sides of our equation. Let's do this. The integral of dy over y is equal to the natural log of y plus some constant c1. The integral of x is equal to x squared over 2 and plus some constant c2. Now let's subtract the constant c1 from both sides, and we'll have the natural log of y is equal to x squared over 2 and plus some constant c. Or we can rewrite it as y is equal to e to the power of x squared over 2 and plus some constant c. Great. Now let's get down to the next one. And this equation seems to be a little bit easier, and yes, it's actually easier. So you see that the only thing we need to do is to multiply both sides of our equation by dx, and let's do this. So we'll have dy is equal to x times dx. Again, you see we have all our y's on the left hand side and all our x's on the right hand side. So at this point we can integrate. The integral of dy is equal to just y. The integral of x times dx is equal to x squared over 2 and plus some constant c. Great. Now let's get down to the next one, and this one seems to be a little bit more complicated. However, it's not so. Let's try to apply the same logic here. So let's, again, divide both sides by y times 1 over y. And we'll have dy over y times dx is equal to x squared plus 1. The same thing, we need to get rid of this dx and place it here. So let's multiply both sides by dx. And we'll have dy over y is equal to x squared plus 1 times dx. Again, we see that we have all our y's on the left hand side and all our x's on the right hand side. So at this point we can integrate. The integral of dy over y is equal to the natural log of y, and the integral of x squared plus 1 times dx is equal to x cubed over 3 plus x and plus some constant c, or y is equal to e to the power of x squared over 3 plus x and plus some constant c. And let's finish our video with the last equation, which seems to be even more complicated than the previous one. Well, So what can we do at this point? So let's get rid of this cosine of x. So let's multiply both sides of our equation by cosine of x. And we will have dy over dx times e to the power of y is equal to 2 times cosine of x. Great, again we need to get rid of this dx. So let's multiply both sides by dx and we will have e to the power of y times dy is equal to 2 times cosine of x times dx. Again, we have all our y's on the left hand side and all our x's on the right hand side. So let's integrate it. Uh-huh. So the integral of e to the power of y times dy is equal to just e to the power of y plus some constant c. Let's make it look like a c. The integral of 2 cosine of x times dx is equal to 2 sine of x plus some constant c. So e to the power of y is equal to 2 sine of x plus some constant c, or y is equal to the natural log of 2 sine of x plus some constant c. Well, thank you for watching my video. Don't forget to hit the like button and subscribe to my channel.